Hello, I'm Mr. McBrien. This is TEJ4M, Mathematics and Engineering. Today I'd like to talk a little bit about the importance of mathematics in engineering and science. We are going to review power in a circuit because we'll use that as an illustration for the concepts we want to talk about. And then we'll talk about reporting calculations in TEJ4M and how to make sure that our marks are the highest they can be in every course that we take that involves mathematics. Okay, so why is math important? You've probably already got a sense for this, but it's worth reiterating that mathematics is really the sciences, the language of science and engineering. In science, most of our observations are in some kind of number form. We try to look at trends in terms of those numbers. We consider a concept understood if we can make predictions of what numbers will be for new experiments and then confirm them. So we need to talk about some kind of math, so we're going to use power in a circuit as an illustration. As a review, power is the energy consumed per unit time. And power in a circuit is pretty easy to calculate. It's proportional to the current and to the potential applied. So P equals IV. We're going to use the power equation as our target example for the process we're going to talk about today. What's that process? Well, we can call it guessing. And guessing is a way to increase the marks that we get when we report the results for mathematics problems. It's really pretty simple. It has three main benefits. It helps us with our thought processes. It makes marking easier for our teachers and instructors. And it increases the chances that we can be given part marks when we get the answer wrong. It should be able to, if you apply the guess process, should be able to improve our marks across math, science, and engineering. So as you might have guessed, GUESS is an acronym. It stands for 5 things, including the givens, the unknowns, the equation, the substitution, and the solution as part of our answer for a given question. Hopefully you're still here and haven't left because of the bell. Okay, so our givens. When you are putting down an answer for a question, start with the values that are relevant from the question that you've been given. Writing these down helps you form your thoughts, and it identifies the equation that you need to use. So, in our example, we're going to calculate the power consumption in a circuit that has a current of 0.003 amps at a potential of 9.0 volts. And our givens are pretty obvious, really. I is equal to 0.003 amps, and V is equal to 9.0 volts. Now, I need to emphasize that you're not just going to identify these things. You're going to write them down each time you solve a problem. Now, the unknowns, pretty simple as well. The unknown is just what the question's asking us to solve. So all we have to do is write something close to this for the U term in our answer. So we would just simply write something like V equals question mark. The value equals question mark. Now for our specific, and I should note that in TEJ, successfully recording the givens and the unknowns gets you a half mark on the question, even if you have no idea what you are doing. So you'll receive a half a mark every time you successfully identify the givens and the unknowns. Because it may not seem like it, but you're actually interpreting the question and you deserve to get some marks for that. Okay, back to our question at hand. We've identified our givens. The unknown, of course, is the power. So we can identify that from the word problem. The power consumption is the unknown, and all we have to do to finish the what we need to get the half mark is just write P equals question mark. The unknown is the power. All right, half mark achieved. The next item in the guess process, the equation. All you really need to do is write the equation that you're going to use. When you write this down, it helps you identify if it's in the right form or not. It helps you avoid transcription errors, and knowing the equation that you need to use gets you a full mark on the question without you getting necessarily the right answer. So we go back to our question at hand, and our equation, of course, is just P equals IV. Now we're not quite done. We need to identify if the equation is in the right form. So obviously we need to see the item we are looking to solve for alone on the left, and the values that we possess on the right. And if we don't have this, it's time to apply algebra. So in this case, it's really easy for us to spot that our unknown is on the left, just like we want, all alone on the left, and the values we have are on the right-hand side. So our equation's in the correct form, and we can proceed to the next step. Okay, so the next step with the equation in the right form is substitution. So what we want to do is simply substitute in, putting the net values into brackets. When we write in this substitution, there's a benefit to this. It's easier to check our work if we want to go and check with the calculator a second time. It's easier for us to verify that we've substituted in correctly without any transcription errors, and there's a half mark for the successful substitution. So back to our equation at hand. We can take our equation, and for I, we can put in brackets 0.003 amps. For V, in brackets, we can put 9.0 volts. And voila, 1/2 mark. And now it's time to get out the calculator. I know I've emphasized this a number of times. If you don't have a calculator, it's time to go out and buy one. Use your calculator not just in tests, but use it for your homework as well, because you need to practice how you play. So you need to practice using your calculator so it doesn't add additional stress during tests. And of course, bring your calculator along for quizzes and tests. You will not be allowed to use your phone in quizzes or tests. Okay, so the final step is just to calculate the solution to the problem. Almost the final step. So our solution is 0.003 times 9, or 0.027 watts. Now, we're not quite done. The guess process is complete, but a very significant part of proper mathematics problem solving is not complete. And I'd encourage you not to stop here. So what am I talking about? I'm talking about the 3 questions. If you've been in my class before, I've emphasized the 2 questions, of course, but now we're in grade 12 and there's a 3rd question we need to ask ourselves. So before we move to the next problem, and before we, if we're practicing, before we check to see whether we've got the right answer, we need to ask the 3 questions, and you need to practice this just as much as you practice any of the other techniques you use. So the 3 questions, 2 of them are familiar from past classes. The first, what are my units? The second, does my answer make sense? And the final question, how many significant figures can I report? You need to practice this technique. I can't emphasize this enough. You need to practice it when you do your homework, and you need to do it before you look at solutions to the questions. And this way you can identify when you make mistakes. It's a gain, it's a practice how you play situation. You need to practice how to maximize your chances of getting the right answer. And a little tip. Try practicing underlining the answer as you ask yourself the 3 questions. It will remind you to do so, to ask those questions. It'll also help teachers with marking your exams. It's a very good habit to get into. Okay, so back to our question. Our solution was P equals 0.027 watts. And if we were in grade 11, that would be a correct answer. We could underline it. We can say that it's a pretty small circuit with low current, and so the answer is reasonable at a very small wattage. No big deal. We can say that our answer makes sense. And of course, our units, watts, are a unit for power, so that sounds pretty good. But when we get to the third question of how many significant figures, we can identify that our potential has 2 significant figures, but in fact, the current only has 1 significant figure. And so, before we underline our answer, we need to round it to 0.03 watts. And that, in fact, is the correct answer. Okay, should we try another one? All right, voltage in a circuit. A Tesla motor claims 325 kilowatt output, or 325,000 watt output. Its battery has a maximum current of 1500 amps. If we assume 100% efficiency, what's the voltage produced by the batteries? Okay, so we can identify our givens, the G from guess, pretty easily. Given 1500 amps and 325,000 watts. Our unknown is the voltage. The equation P equals IV, and okay, our equation is not in the right form, right? So V is not on the left-hand side and isolated, so we won't be able to simply substitute into this equation. So now it's time to do some algebra. When our equation's not in the right form, I know you know all of this from the past, but it's worth emphasizing. We use algebra to isolate the value we need. We need to isolate the V term, and we identify that unfortunately V is multiplied by I in this equation. So we need to get rid of that I times V, that I times part of it. So to get rid of it, we do the opposite. So instead of multiplying by I, we divide by I. So we decide to divide by I in order to isolate V. Now to keep that equation equal, we need to do the same thing to the other side. So we need to divide that by I as well. And at that point, we've isolated V. So how would that look on our paper? We would probably write something like this. The equation P equals IV. Divide both sides by I. Cancel I from the right-hand side. And we get V equals P over I. And that's the equation we write down to get our full mark for the equation. Okay, so then we're on to our substitution portion. And we can substitute in 325,000 watts for P, 1,500 amps for I. Then we move on to the solution stage and plug it into the calculator. And when I did the calculation, I got 220 volts as my answer. Are we done? No, we're not. We still need the 3 questions, right? Okay, so we're not quite done. Now we need to ask ourselves the 3 questions. So, first off, are our units there? Yes, our units are volts, and that's the correct value for potential or for voltage. So that part's fine. Is the number reasonable? Well, 220 volts, it's a bit hard to understand whether We don't know much about Tesla cars, but what we can say is that 220 volts is a number comparable to line voltage, right? So it would seem somewhat reasonable. So we can go ahead and take ourselves to the significant figures portion of that number. And when we look at significant figures, we can see that these numbers, it's a bit ambiguous. We can't be sure whether the number of significant figures here is 6 or whether it's possibly 3. We know it is at least 3. Same thing, 1500 amps, we can't be sure that this is not 4 significant figures. In computer engineering, we'll use the convention of putting a dot behind the 0 in order to signify that that's 4 significant figures. So we can assume here that this is 2 significant figures with the amp term. So based on that, we can only report 2 significant figures in our number, and so we've rounded to 220 volts. So 2 significant figures here, 3 here, 2 here. We can only report the lowest number that we see, therefore 2 significant figures. 220 volts is our answer. And we can go ahead and underline it at that stage. Okay, this might be a good time for us to illustrate the value of the 3 questions. So let's imagine our question here, and let's look at our correct equation. B equals P over I. And we correctly substituted in here, but let's imagine for a second we had made a mistake and we'd accidentally multiplied. Either a calculator error or an algebra error when we did the original modification of the equation. So we would have plugged in 325,000 times 1,500. And our answer would have been, looks like 490 million volts. Now, when we go to ask ourselves the 3 questions, we can say, okay, the units are correct. The sig figs are correct. But when we get to the question of, does the answer make sense, we haven't seen many instances. Maybe you have. I haven't seen many instances where someone has reported 490 million volts as a potential. And so this would be a heads up for us to go ahead and maybe check over our question one more time before we underline the answer. I guess what I'm saying is the 3rd question is really asking you to use your gut. Does the answer feel right? And that's the question for you to ask yourself. Okay, so let's sum up. We're all pretty much aware math is the language of science and engineering. We redefined power gain as the amount of energy consumed in a circuit per unit time, and we covered the equation for power gain. We've introduced the guess system of reporting solutions to problems, and this is a way to help you guide your thinking, to increase the marks that you receive, and to make it easier for teachers to mark your tests. We also talked about the 3 questions, a way to reduce the marks that you lose, not just through TEJ4M, not just through high school, but also throughout university and college. Okay, so some follow-up work. Go ahead, please, and complete the Mathematics 3 TEJ worksheet, and have a wonderful day.